About exponential graphs. Exponential graphs look like this. Exponential graphs normally have a horizontal, you're not drawing this, we're just remembering, horizontal asymptote at y equals 0 because it's the x-axis, right? We don't write AJ on a test, but that could be you laughing at yourself. Ha! You know what I'm saying? Or ba for vertical. Okay, if it's an exponential, that was funny, no one laughed, it's fine. I'll be here all week. Okay, that's an exponential what function?
Growth function.
Yes, growth. And this is an exponential what function?
Decay function.
Decay function. Those were answered correctly. Exactly what I wanted. Yes. All right. So what's the only thing that can move the asymptote? Vertical translation, right? Your vertical translation is your horizontal asymptote. We agree? Your vertical translation is your horizontal. And your domain is always x and L in the reals because it goes on for life both ways. But our range can be greater than, not equal to, it can be greater than our horizontal asymptote, or it could be less than our horizontal. What's going to happen in order for it to be less? Reflection in the x-axis. Your y has to be negated. It's range. What's the only thing that affects range? Your y values, right? So your y needs to be negated. If your y is negated, it's downwards. Okay, it's less than. All right, logs and exponentials are inverses of each other. So that's what we're going to talk about today. So this is what a log function looks like. Can you type log x into your calculator? Because log base 10 of x is log x, right? So go to your y equals and type in log x. Every single person do this. And then you're going to listen to me and not listen to and not do this on the test anyways. You're going to ignore me, and I'm going to be sad. Or you're not going to ignore me, and I'm going to be happy for once in my entire life. Well, since 2012. For this lesson. I'm happy for lots of times since 2012. But for this lesson, for this question on the test, people will give it to me. Wrong. Now, it looks like, guys, on your calculator, I don't know why, your calculator can get really close to the x-axis and keep drawing. But when it gets really, really close to the y-axis, it's like, I'm done. Like it just stops drawing, even though it actually still draws. So on your calculator, it'll look like this. That's still blue. That's not helpful. It'll look like this. And people will tell me the range is greater than 2 and equal to negative 2. No. Remember, exponential functions have domains of XER, correct? Logs are inverses of exponentials. So that means x's become y's and y's become x's, right? Domains become ranges and ranges become domains, right? So if an exponential function has an XER domain, a log function is going to have a what range? YER, because your x's and y's switch on logs and exponentials because they're inverses, right? So even though your graph looks like it stops, guys, it keeps going. And then on the test, you will tell me y is greater than or equal to negative 2 every time. And I'm just like, my calculator shows that. I'm like, you're smarter than your calculator. Okay? Your calculator, for some unknown apparent reason, stops. It's like it gets overwhelmed and it quits, like you guys do sometimes, right? So your calculator gets overwhelmed and it quits. Now someone laughs. Thank you. All right. When I cut you down, you laugh. Good. I've learned that. I've learned what I need to do. Okay. So this one has a what on it? A vertical asymptote. Now, if I have a horizontal on an exponential, I have a vertical on a log because they're inverses of each other. Correct? That's what they are. So this one has a vertical asymptote at what? Shockingly, x equals 0. Because the other one had a horizontal asymptote at y equals 0. Remember, our x's and y's just switch. Logs and exponentials are just inverses of each other. Right? So now on an exponential, it's XER. So on a log, my domain will not be XER anymore. It'll be something. We'll deal with that in a second. But my range is going to be y such that y is an element of the real. Exactly. Or in interval notation, negative infinity to positive infinity between that interval. Now, what is the domain? So our range was y is greater than our asymptote, or y is less than or equal, or less than our asymptote, but not equal to, right? So what's this one going to be? X such that x is greater than 0. Right? Nothing crazy. Inverses are exponentials and logs are inverses. So the domain becomes a range becomes a domain, x-intercept becomes a y-intercept becomes the x-intercept, right? Everything just switches. All your x's and y's switch. So an exponential can draw itself along the x-axis for some unknown reason. Your calculator can do that. But when it gets to doing logs, it gets overwhelmed and it stops. But the graph doesn't actually stop. The graph drawing stops, but if you went to second, like if you went to just your table keeps going. Even though the graph stopped drawing, it's like it can't do any more pixels. It like freaks out. But your table of values shows that it keeps going. It doesn't just stop at -2 or whatever it looks like it stops at. The table of values, the y values will keep going. All right. So here it says, use transformations to sketch the graph of y equals log 2x minus 2 minus 1. First off, before I do anything about transformations, I have to do what? Make sure it's in y equals and a 1 in front of the x. The 1 in front of the x means it's a standard of excellence question, the moment there isn't a 1 there. So make sure you check for it. I've never seen a test where they don't have that. I've never seen a test that I've given where I don't do this. Right? I will always put, for at least one question, not a 1 in front. So I get a 2 bracket 1x minus 1 minus 1. Okay, guys. If an exponential function has a horizontal asymptote, and the only thing that can move the horizontal asymptote is the vertical translation, so the vertical translation is the horizontal asymptote, correct? Now we have a, what on a log? A vertical asymptote. What's the only thing that can move a vertical asymptote? The horizontal translation, right? If it's vertical line like this, the only thing that can move it is doing this or doing this. Which way am I moving?
Sideways.
Sideways, aka?
Horizontal.
There we are. Yeah. You got it right again, but we're back to, I'm glad. You know, I felt a little scared for a second. All right. So we know that this baby right here tells me my horizontal translation. What is my horizontal translation? 1 to the
Right.
right. It was at 0. It's now 1 to the right. So I have a vertical asymptote. At x equals 1. Remembering that our horizontal translation is our horizontal asymptote. Now, in order to sketch this baby down here, we want to use original points off of our log, just the log base 10 graph. So you've typed it into your calculator, you typed in log base 10, or just log, because log x is log base 10, and we go to our table of values. Now it's erroring when x is 0, -1, -2, negative. It makes sense, right? Our x's don't exist behind 0, right? For our log. But we have our normal points, 1, 0, 2, and 0.3, 0, 1, 3, 4, 7, 1, whatever, 2, etc. So what I'm going to get you to do is I'm going to get you to type this one in. Try and type that one into your calculator. What base is that log? It's 10 as well because it doesn't have a base, right? So go right to your calculator and type it right in. Yeah?
Type it in mine too, or just...
You can just type it into your Y one, it's fine. Clear out the other one. 2 log 2x minus 2. Now I'm typing in the original because everything I touch doesn't always turn to gold, so I'm not going to go based off of my fixed one, so I want to check it out. Wow, it looks like it stops at -3. So I should say y is greater than -3. Maybe equal to -3. Right? That's the range. On a test, that happens every time. Makes me so sad. Remember, exponential has an x that's XER. Log has YER, right? It looks like it stops, but does it actually stop? No, the calculator just stops. Go second, graph. Go to your table of values. So we have, if we go down here to sketch it, we have we have 2 and -0.39. So it's here, right? What do we know? We know there's an asymptote where?
One.
At what one?
X equals 1.
X equals 1. So we know we have a vertical asymptote at x equals 1. So I draw that right away. Then I go to my table of values. I have 2 and negative 0.39. I have 3 and 0.2. I have 4 and 0.55. I have 5 and 0.8. I have 6 and 1. 7 and 1.15. 8 and 1.29. 1.14. So I know it's doing this. And then I get usually people doing this. That looks like it goes there. And then they stop. Remember that there's other values. Your calculator only right now, your calculator right now is giving you at ones, a ratio of 1, x values change in 1, right? Let's try this out. Following along? Go second window. That's what your table is set at. That's how it talks to your table set. So if my table starts at 3, because that's what I have. You can start at 1, 0, whatever you want. Then I have my change in table, so my change in x is 1. So all my x's are changing in 1, right? What if I go 0.2? Just go 0.2. Make that your change in x, change in table. Delta table. Now I go second table. Now I have more that I can plot. So I have 3 is at 0.2, is at 0.2, and then I have 2 is at 0.39, then I have 1.8 is at negative 0.5, and then I have 1.6 is at negative 0.84, and then I have 1.4 is at negative 1.1, 1.2 is at negative 1.7, and then 1 I get an error. Could I have more? Yes. What do I know happens with this graph? It's like a cow trying to cross this fence. It gets closer and closer. The asymptote's an electric fence. The cow gets closer and closer to it, but it doesn't touch it even though mine's doing it because I can't help it. And it runs all the way down. Why I use green on green? I do not know. Try again. So even if your log graph looks like it stops, it doesn't. It just can't draw closer to that asymptote. It just gives up. It quits, even though it does keep going, right? So on log graphs, when it looks like it stops, please don't tell me it stops. It does not stop. Okay, just draw it along that asymptote with an arrow at the end. Does that make sense? It looks like it's stopping, but it's not stopping. Your calculator keeps going. Yeah. Yeah, or you could just type in values. Remember, if I want 1.1, can I not just go second trace, let's try this out, second trace value, and I can put in any x I want, right? So I can put in 1.1, and I get an x for it, right? So you don't even need the table of values if you want to get every y for every x. You can just go second trace value 1, second trace value 2, second trace value 1.3, second trace value 1.004, right? Like if I go close to 1, second trace value 1.0005, it now tells me it's at negative 7. Everyone do that because it'll actually draw it even though the calculator didn't draw it for me. Go second trace value 1.0005. I wish I used my other computer that has that calculator on. It tells you it's negative 7. It actually shows it drawn, but the calculator didn't draw the graph there. I don't know why. So if you go second trace value 1.0005, 3 zeros and a 5, you get negative 7. So the graph keeps going, correct? It just looks like it's not. Do you believe me? Like it just drew it there, even though there's no graph there. And I don't know why it does what it does, but it does. It drives me crazy because you all trust your calculators too much, not your brain. Okay. So, what's the domain? What's my domain of this one? Is there a reflection in the y? No. So my domain is x such that x is greater than 1 XER. In set notation, in interval notation, 1 to infinity. And then my range? What's my range of every log function? YER, even though your calculator looks like it stops, right? Because the domain of an exponential is XER, and they're inverses of each other. So in set notation, it's y such that y is down the reals, or negative infinity, positive infinity. X and y intercepts. Is there a y-intercept? No, this one doesn't have one, right? Because I shifted it completely right off of it. Now, how could I get a y-intercept? Instead of going one to the right, what would I have to have done? You can go one, anything to the left would pull it over to get you a y, right? Or if I reflected it in the y-axis, it would cause it to have a y as well. Okay, so this one has, let's try it out. If I want an x-intercept, what do I say? Every single time I say x-intercept, I should say y-intercept. Like when I say what time is it, you say nighttime. When I say x-intercept, you say y equals 0. Like this should be part of your being. Like even if all the math falls out of your head, that should be what you should say. Okay? So we're going to do it algebraically. So we go 0 equals 2 log 2x minus 2 minus 1. I always plug it back into the original. Now I need to get x by itself. The moment I go to do anything and it doesn't have a base, I put a base in. What's my base? 10. Oh, I have an eraser. Good. Didn't know that. Okay, so how do I get x by itself? I can convert to exponential right now. Can I? No. Base my log comes base my exponent. What's with it? Oh, there's so many things. So many things. So I have to first actually add my 1 over. So I get 1 equals 2 log base 10 of 2x minus 2. Then what do I have to do? I still can't convert it. Someone I heard whispered it. What do we do? Divide by 2. So I get 1/2 equals log base 10 of 2x minus 2. Okay. Can I convert now? Yes. The base of my log becomes the base of my exponent. What's with it? What's friends doesn't stay friends, so I get the 1/2 equals 2x minus, don't want to do brackets. 2x minus 2. That's annoying. Okay, so I add my 2. So I get 10 to the square root of 10 plus 2 equals 2x, and then I divide by 2. So if they want an exact value, this is the exact value of your x-intercept. So it'd be root 10 plus 2 over 2 and 0. If they ask for it as a decimal, we just type it in. 2.58 and 0. Now what if I want the y-intercept? What happens? When you hear y-intercept, when I say y-intercept, you say x equals 0. It should be a cheer. So we get y equals 2 log base 10, 2 times 0 minus 2 minus 1. Y equals 2 log 10 of negative 2 minus 1. What can't I have in a base of a log or beside the log? A negative. You type this in, your calculator's going to get mad at you. Right? So when this doesn't work, when you get no solution, because you type it in and it doesn't work because you can't have a negative beside your y, you have no y-intercept, which we saw we have no y-intercept. But this is algebraically how we prove that. Then we're going to flip over. So here it says, determine the transformations associated with each of the following. So once again, like with exponentials, we have to have the same base in order to compare them, right? Like we have base 3 to the x and then base 3 to the x plus 2. That base 3 doesn't appear anywhere in the transformations, right? But they have to be the same. Same thing with logs. I have a log. How does this, the following from y equals log base 3 of x? Well, here I have y equals log base 3 of x. Same thing, right? Does that 3 appear anywhere in my transformations? No. Just like the base 3 in exponentials doesn't appear anywhere.
Very sorry for the interruption.
All right. Can we say transformations the way this is sitting? No. What must we need? 1 in front of our x. You all say it so greatly, and then the test you don't do it. But I believe in you. This test will happen. Okay? I believe. So we get 2 log base 3. And we take a 2 out, and we're left with x what? Minus 1/2. So, what are my transformations? Does this 3 appear anywhere?
No.
No. I have a vertical stretch by a factor of 2 about the x-axis. And then I have a horizontal stretch by a factor of 1/2. Oh, guys, you've come so far. Like a proud mom. Half about the y-axis, and I totally could be your mom, right? But I'm not. But I'm the age. So, good job, guys. Feel like my children have all grown up. Good job. All right, now don't mess it up from here. You're gonna make me so sad. Okay, what do we do? That 3 goes? 3 goes? Nowhere. Yes. And you answered exactly what my brain was thinking. Yay. And then the half goes where? What is it? Horizontal translation in trig, what is it? Phase shift. Horizontal translation, 1/2 units, where? Right. And then I want mapping. X, Y becomes 1/2 X plus 1/2. Remember, words and mapping are the same. And then 2Y. And then we want domain and range of previously transformed equations. Well, before we do the domain and range, well, actually, range we can do easily. What's the range? It's a log.
Negative infinity, infinity.
Yeah. So in interval notation, negative infinity, infinity. My brain's going for set notation, so glad to know we're still a little off track,
Yep.
but in the same place. So y such that y is an element of the reals. The domain is easy if we know the asymptote. State the equations of the previously state the equation of the asymptote. That's what this is supposed to do. What's the asymptote for this one? Horizontal or vertical? It's a log. My pen is giving you hints, but you're not saying it. Vertical. Asymptote. What's my vertical asymptote based off of? What's the only thing that can move my vertical asymptote?
Horizontal translation.
Horizontal translation. So I have a vertical asymptote at x equals
2.
so close. 1/2. Has it been reflected? Has it been reflected? Is the x negative in my... No. So my domain is going to be greater. So unless I have a negative with my x, a reflection in the y-axis, my domain is going to be x such that x is greater than a half. Or a half to infinity. Do you know what's awesome? The next two. That's what's awesome. What do I have to do with b first? Divide the 3 into every term. So this one and that one. And what do I have to do with that one? Minus the 3 and? Get a 1 in front of the x. Get one of those two. All right. I want you to give me the transformations and mapping for both, the domain and range for both, and this. Then I also want you to do 7, 8, 9, numeric response 10. That's your homework. Ignore this. That's way more. So we're going to be happy with what Mrs. Lepp gave us. So get working. We're going through it tomorrow.